Hello everyone, my name is Lee Pucker. I'm the CEO of the Wireless Innovation Forum, and I'd like to welcome you to today's webinar on SCA standards for defense communications. Before the webinar begins, a couple of administrative notes. First, a question we always get asked is, can I get a copy of the slides? The answer is yes. We'll be posting them online. The slides will be at wirelessinnovation.org/webinars, tutorials, and resources. Second point is we're going to send out a satisfaction survey to everybody who's online just to get your feedback on how well we did with the webinar and things we can do to improve it in the future. We ask that you please fill out this. We really take the feedback that you give us very seriously in looking at how we can make this a better experience for everybody in the future. Final point is if you have any additional questions, please feel free to email me directly, lee.pucker@wirelessinnovation.org. A little bit about the controls. You can see here what your control interface looks like. Everybody, I believe, would have dialed in by now, but if you haven't, there's a couple of modes of audio that you can work with. You can expand or contract your control panel using the little double arrow key. From an audio perspective, if you're just listening on speakers, you can do that right through your computer. If you're dialed in using the phone, go ahead and do the phone number, and then remember to put your audio pin in, and that gives you, again, access to the controls from the little control panel that you have there. There's a couple of windows that you can use. One is the questions window. The speakers today have asked that we handle questions at the end. However, I'll be receiving the questions, so if you type a question into the questions window, I get it in real time. If it's something that I can answer right away, I'll just type you the answer back. If it's a question for the speakers, then I'll ask those at the end. So feel free to type your questions as they go, and then we'll manage them at the end of the session. The second is there's also a chat window. So if you'd like to share your thoughts with others who are participating in the webinar, then go ahead and feel free to type something in the chat window, and we can do that. Last thing is at the very end, there's a little hand symbol. If you click that, it basically is raising your hand and asking to speak. At that point, I'll turn your microphone on, and you can ask your question directly to the presenters. So with that, I'm going to turn the webinar over to Eric Nicolet. Eric is from Thales Communications, and he is the co-chair of the Wireless Innovation Forum's Coordinating Committee on International SCA Standards. Eric, I turn it over to you.
All right, Lee, thank you very much.
Okay, Eric, you should have control.
Yep. Do you see my screen?
Yes.
Okay. Okay, so we should be.
You're in full screen.
So I should I should display the agenda section. Is it correct?
Yes.
Okay. So welcome everybody. It's my pleasure to be the second to introduce this webinar. Moving forward from the techniques of the webinar itself to the agenda and some basic introduction to the SCA. This basic introduction to the SCA will be the point I'm going to develop in the what are SCA standards section. Then Ken Digman, the other co-chair from Harris Corporation, will go on with the global adoption proven performance aspect, and I will be back on stage for the WINF Coordinating Committee on International SCA Standards topic of this agenda. Finally, as Lee Pucker introduced, we will manage the Q&A session based on the questions you will have asked using the message, the question box you have access to thanks to the control panel of the webinar tool. So the webcast presenters will not only be myself and Ken Wigman, a number of panelists from the members of the steering group of the coordinating committee will take part to this webinar, giving their perspective. Those are Ugo Manetti from A4SO, David Renaudot from Thales, Fabio Casalino from Selex, Ken Dingman from Harris, and Rüdiger Leschon from Roden Schwarz. And you already heard Lieper Kerr, who is the moderator of this webinar. So let's enter into the core of this presentation with an overview. Of course, we will not enter into the details regarding what are SCA standards. So what we mean by SCA standards needs to be understood with the meaning in the S of standards. So what we call SCA standards are standards based on or supporting the SCA. The SCA, the Software Communication Architecture, that is an architecture framework created to assist in the development of software-defined radio communication systems, allowing waveform application software to be more easily ported across radio platforms. We're going to drill a little bit inside that in the coming slides. So what needs definitely to be understood is that there are several standards that can be considered as SCA standards. The so-called, all of them, are publicly available specifications. One of them is the SCA dubbed 222.2.2, and the recently released 4.0, which corresponds to the core framework and the operating environment for especially general purpose processors, GPPs. It is based on a number of appendices that are other so-called SCA standards that describe some specific aspects of specification that take place in the big picture introduced by the core specification. And the third bullet you see in this gross categorization of standards is the SCA APIs, and those animals are quite different, but they do belong from our perspective in the SCA standards family. Those are APIs enabling the waveform application to interact with the underlying hardware platform or software platform, thanks to specific APIs that correspond to the different sort of peripherals or signal access mechanisms that the platform is delivering to them. More on that can be seen on the WINEF website at the URL you see at the bottom of this slide. One of the key aspects related to why adopt the SCA is the so-called reconfigurability aspect. This has to do with the fact that a given radio, and you have an example on the picture, is capable to host, thanks to the deployment mechanism, a diversity of waveform applications. Meaning that the radio, typically if you have a single channel radio, and that's part of a given radio is capable to successfully host or execute waveform 1, then waveform 2, then waveform 3. You may have more complex or elaborated system where you have multiple channel radios, each channel being capable to host a specific waveform. And at the end, what the SCA is providing, thanks to its core framework and the way this core framework harnesses the equipment, is the capability to have the radio set, the SDR set, successively execute different waveforms, switching from waveform 1 to 2, 2 to 3, back to 1, depending on the missions that needs to be realized by the user of the radio. So that's one key aspect behind SCA, especially behind the core framework. It is the engine, the machine that is capable to install the different waveform applications and to harness what's the underlying software platform that hosts those applications in order to reconfigure the radio from one application to others. This reconfigurability story concept is of course close to a user experience, and it has to do with direct operational aspects. The other piece of the coin, making it of course extra simple in this presentation, is the concept of portability. So here it's not anymore an operational perspective, it's more a procurement perspective or an industry perspective concerning how we make those radios. And portability is the concept to say that you can easily reuse waveform software developed for a given waveform application and distribute these waveform software from on top of a number of compliant radio platforms. And this has to do with the porting concept that consists in taking a piece of software that represents a waveform, not a piece of software, a whole stack of software exactly corresponding to a waveform, and porting it on a number of different platforms. Those platforms can be platforms of the same vendor. Those can as well, depending of course on the various industrial contexts we encounter in the SCA ecosystem. The platforms can belong to different vendors or manufacturers, and the waveform itself can come from government-owned repositories, can be industry proprietary, can be shared or distributed across a diversity of licensing and business models. So the key concept around that and the key rationale around that is that portability is definitely a help to achieve interoperability between the radio equipment at reduced cost. So I like to dub that in saying this has to do with interoperability affordability. Thanks to the porting capability of this stack of software you are seeing on the top, you will minimize the risks to have different interpretation from a given waveform standard spec, and therefore this helps in achieving interoperable solution, because at the end what counts, and we are back to operational something, what counts is that of course the different radio platforms communicate each other over the air, and this is what interop is about. So the two previous slides depicted the two big things that SCA standards are providing, and this third one, graphical one you're seeing, is illustrating a little bit more what was introduced with the 3 bullet points 3 slides ago, in terms of, okay, what do we have more precisely inside those famous SCA standards. On the top of the picture, you have the waveform software. So that's at the core of SDR concept, of course. You have this software that makes the signal processing, the protocol, all those number of things that represent the operation a given radio is doing for the sake of communicating over the air. So that's this waveform software, which is to be installed inside the and executed inside the radio equipment, and this is to make things simple. What the SCA core framework you see on the left-hand side in the middle is about. So thanks to a number of APIs, the user of the radio set can select which waveform among the available ones is to be executed. And then this SCA core framework installs the corresponding software and runs it And after some moment in time, which is called the deployment process, then the radio application is capable to operate. This waveform software, because it has to do with hardware, it is running on hardware, needs a number of things which are characterized in the SCA appendices API, which are the blue things you see at the bottom. A number of sub-rectangles are quoted to illustrate what's inside that. Those are standardized technical services, so software things that enable the waveform software to execute. The middleware or the transfer mechanism you see correspond to the capability, the software capabilities based on the buses, etc., and communication means from the radio equipment that enable the different software components of the waveform software to communicate with each other. Because the waveform software is not executing on a given processing element, it is distributed over a number of processing elements, typically GPPs, DSPs, FPGAs. So there is a need for communication means, and SCA appendices with the core bar recommendation with some other possible transfer mechanisms are defining how the waveform software components can communicate with each other. Other kind of thing is the POSIX operating systems, the access to the kernel that's on ultra lightweight or lightweight profiles are enabling, which are other key, especially for general purpose processors or DSPs aspects, that enable the software components to correctly execute. All of that at the end, those things in the blue rectangle, are the standardized items that each platform needs to provide for the sake of correctly executing the waveform software, and what they provide are technical services that help the waveform software to execute or enable it to execute. But that's not enough. A software, in order to execute, especially when we're dealing with radio, where you have an antenna, where you have a number of key ancillaries, typically such as GPS, etc., and you have as well the I/O sources from the users, there is a need to access and exchange a number of data that are coming from the underlying hardware. You have as well an essential requirement, especially in the military domain, that has to do with securing the transmission. So in addition to the blue things that are software technical services, the big family of radio devices and services which are specified via devices and services APIs. This was the third bullet of the slides 3 slides ago. These series of APIs are enabling to characterize what the waveform software is allowed or to use, and it is up to the platform provider to develop the corresponding, let's say, drivers that will deliver in a standard compliant way that is characterized by the device and service APIs to deliver the corresponding service to the waveform software. So the quotes here, examples, are audio corresponding to accessing to a user speech signal or giving out the output audio signal to the headphone of the user. The security has to do with accessing the InfoSec module. A transceiver has to do with accessing to the signal captured over the air by the antenna system, and all what goes along in terms of digital analog and digital down conversion and reciprocally in transmit. Ethernet is an example of a typical output socket that can be the endpoint of the waveform software. At the end, generally speaking, we see here each of those rectangles more or less correspond to a given standard. And those are dubbed as the so-called operating environment, OE, which is a terminology that is very, very often seen in the SCA ecosystem. And at the end, the SCA standards we are talking about corresponds, to make things simple, to each of the individual rectangles you've seen on this slide. I guess that's it as far as I am concerned, and I will now turn ask Lee to turn the control to our next speaker, who is Ken Digman from Aris Corporation.
Okay, Ken, you should now have control.
Okay. Can you see the presentation?
Yes.
Okay, great. Thank you, Eric, and thank you, Lee. So the SCA, as Eric has pointed out, covers a wide category of technology and capabilities, and it really is being adopted globally and has proven performance through a number of different programs that have adopted it and are using it. Some of the real advantages of it are, given that it's a common platform, it really assists in the reuse of waveform application software from one vendor to another vendor, or even within different platforms, different radios within an individual vendor. It really, one of the original goals, primary goals of the SCA was to enhance and enable interoperability. And it does this by providing the common platform that allows the waveform to be easily ported from one vendor's radio to another vendor's radio. And by making it much more cost-effective and technically efficient to move waveform applications between vendors' radios, the interoperability situation within the services is greatly enhanced, thereby having the same waveform application on different radios from different vendors, so that they can ensure that communications are managed across all the different radios that they have in their system. Really, this can be seen in a couple of different ways. What we see going on in a couple of areas are some multinational coalitions in which a number of nations are collaborating on the development of a platform based on the SCA and also a common waveform that is then used on all of the different member nations' platforms, ensuring the interoperability between those. And as I mentioned also, the other way that you get the interoperability is kind of how it's been done in the US with the JTRS and now the JITNIC model, where a waveform application is kind of defined by the US government, developed by one vendor, and then made available to all the other vendors for them to put on their own radio platforms to ensure interoperability that way. So there are kind of two different ways that enhance the interoperability is being approached, one through a coalition approach and another one where the vendors are doing the development on their platforms themselves based on a waveform that is coming to them from an information repository. Another real advantage of having the SCA and something that it provides, Eric talked about the ability to have multiple waveforms running on a waveform at the same time. Kind of extension of that is the ease of use and ease of loading new types of applications and waveforms onto radios. So SCA applications run the gamut from simple beyond or simple line of sight applications to hopping applications to more advanced SATCOM applications. And now, recently, SCA waveforms are of the nature of MAN-A ad hoc networking applications and supporting capabilities and features, advanced features such as dynamic spectrum allocation. And with the SCA and the ability of the SCA and the core framework to accept these applications as a software, you don't have to do any modifications to your radio necessarily to support those waveform applications. It's just a software load, and a reboot in the core framework now makes those new waveform applications available to the users. So it is quite an advantage in terms of the deployment and the provisioning of new applications as they become available for use. And another significant aspect of what's been going on globally is really the adoption of the SCA and an ecosystem that is being generated to support the SCA. A number of radio vendors have radio products that are based on the SCA, there's tool vendors, middleware vendors, integrators, systems integrators, and development platform providers. Everybody has really come around in creating an environment to support SCA development and thereby make it easier and more cost-effective for waveform development on SCA platforms. So this is a kind of graphical example of how the SCA is being utilized kind of throughout the world. Obviously in the U.S. is where it was developed initially, and there's a large number of SCA-based programs from your HMS, handheld manpack small form factor program, to your airborne maritime fixed-wing program, to other programs like the mid-tier networking vehicular radio and your small airborne networking radio, to name just a couple of the SCA-based programs that are available in the U.S. Europe has also become a large adopter of the SCA, with quite a few number of national programs happening in the European theater. In Spain, you have the TERSO program. Germany has the SVFUA program. France has its CONTACT program. Poland has a national SDR program going on. Sweden has a common tactical radio system program that it's kicked off. Finland has a program. Italy has a couple of different programs, the Forza NEC program and the SDRN program. So that's kind of the activity that's going on in the European area, showing how it's really being adopted in the European area on a national basis. Also in Asia, there's two national activities going on, one in Korea with the Tactical Information Communication Network program, and also the Tactical Multiband and Multi-Role Radio programs. Both of those are ongoing in Korea, and also a maritime SCA SDR program is underway in Japan. So it does show the adoption by nations kind of in all of the, most of the major areas of the world, the North American, America areas, European and Asian. There are also a couple of significant coalition activities going on. One is the SOR program, which is a coalition of 6 nations in the European area, Finland, France, Italy, Poland, Spain, and Sweden. They have extended the SCA 222 to add some specific extensions that were needed for that program, and have defined a waveform to go on that, then each member nation will pick up that waveform and put it on their platforms. And another coalition activity going on is Colwyn, which is a NATO-based activity. So now I'd like to pass it over to Hugo Minetti from A4 SOR program.
Hello, hi everybody. Thank you, Ken. I'm the president of A4SOR. A4SOR is the alliance of 6 European industry. The joint venture has been established in end of 2008, is in charge of managing the SOR program, a major software-defined radio program launched under the umbrella of the European Defence Agency. The SOR program is sponsored, funded by the governments of Finland, as Ken was mentioning before, Finland, France, Italy, Poland, Spain, and Sweden. What we call them participating states. The OCCAR AA, the acquisition agency, European acquisition agency in charge of managing the SOR program and contract. And they in fact have awarded to us, to A4SOR SAS, the SOR contract. The A4SOR shareholder and subcontractors at the same time are the SOR PS respective, what we call national champions, namely Electrobit for Finland, Thales Communication Security for France, Select ES for Italy, Radmor for Poland, Indra Sistemas for Spain, and Sub AB for Sweden. SOR nations and industry have jointly recognized from the very beginning the outstanding benefit of the SCA, the SCA, as the foundation for the SDR military business. What we have developed, the SOR architecture, extended the SCA in order to facilitate the waveform portability, addressing secure solutions for a large scope of military waveform applications. In synthesis, The ESO architecture addresses the following areas: definition of the operational environment for DSP and FPGA processor, providing scalable architectural approach between MAL and CORBA-based solutions, and the definition of extension in addition to the already published JPRS radio devices, radio services, and radio security services APA. I can say that this architecture has already been implemented on 6 different heterogeneous externation SDR platforms. Now we are progressing developing the waveform has to be ported, which again has to be ported on the national platform. That's all I want to say for the moment. Thank you. Thank you, everybody.
Thank you. Thank you, Ugo. Okay, so from the previous slide, the green dots had kind of represented what we consider the first wave, the early adopters of the SCA. We're seeing now that there's a second wave, really, of adopters for the SCA that are coming along. Another set of nations that are starting SCA-based programs or in the process of putting SCA-based programs together. In those countries, countries, for instance, like Brazil down in South America, and in the Asian arena, you have both Singapore and India have SCA-based programs that are underway. And in the Middle East, you have countries like Israel and Turkey and United Arab Emirates that are also investigating and looking into standardization programs that are based on the SCA. So this is a technology and a standard that has been around, proven itself, and is going through a first set of adoption and is now going through its second wave of adoption. So one of the things that's very important is it's not just a technology for the development of applications. It's also a technology and a standard that really supports and highly supports the deployment of the radios. And a large number of radios have already been deployed that have the SCA based in them and have waveforms that are SCA-based waveforms. A few examples of the radios are shown here. One of them is the General Dynamics Rifleman radio, the PRC-154. To date, about 19,000 of those radios have been ordered from the U.S. government, from General Dynamics, and a much larger number of Rifleman radios are going to be procured in the near future. There's also the General Dynamics PRC-155 multi-channel manpack. That's actually no picture of that is shown here, but that's another one where there has been a procurement of an initial set of those radios with about 3,700 of the PRC-155s being ordered so far. From a Harris perspective, there are about 25,000 117Gs, PRC-117Gs that have been deployed to the field so far. That's the manpack that's pictured in the middle. And then there's also a large number of PRC-152 handhelds, about 160,000 of those that have been deployed to the field. Another large quantity of radios has been provided by Thales with the PRC-148 embiter radio, with about 200,000 embiter units deployed to the field so far. So you can tell by those numbers that the SCA really has supported very large radio deployments and has been proven field capable and able to support operational activities in the field. One of the things that's also kind of interesting to notice based on those numbers is that the largest numbers of radios that have been deployed are of the handheld form factor, which is kind of considered a very challenging environment, not a lot of power, not a lot of processing capabilities, and the SCA has been very successfully deployed in that level of a platform. So from a Harris perspective, we have really utilized the SCA and have standardized on the use of the SCA in a large number of radios, supporting a large number of waveforms. We have approximately 6 fielded radios right now that are SCA-based, when being handheld radios for both the international and the DoD markets. We have 2 manpack radios that are currently fielded. Again, one of them is the international, for the international market. Another one is for the for the DoD market. Those are currently released and deployed radios. We also have 2 new radios that are under development, one a personal rolled radio and the other radio that was just awarded as part of the maneuver program. Not quite released yet on either of those. So that's a very large number of radios that we have the SCA in, and we're really able to leverage utilizing the same version of the SCA and the same source code across all those waveform or radio platforms, making it very cost effective and very efficient in the development of our radio software. Across all of those platforms, we also support a very large number of waveforms. And these are legacy waveforms such as Vuelos and HavQuick and SingGars and QuickLook. SATCOM-based waveforms such as DAMA and IW. And we also support a number of networking waveforms from Harris proprietary ANW2 to the U.S. government SRW, W&W waveforms, and we're also putting MUOS now in the products. And having all of the radio platforms utilizing the same SCA platform makes the portability of the waveforms between those different platforms very efficient. So we can quite easily take waveforms that are developed on one platform and migrate them over to another Falcon 3 platform, substantially reducing our development costs and our time to market. So the SCA has been a very valuable tool that Harris has used to field waveforms across a large number of radio platforms. So on the previous slide, I had talked about some of the main government programs, some of the first deployed systems, but there are a lot of other deployed systems. The previous slide had kind of talked about mostly ground-based systems, man-packed and handheld radios, but there's also a significant number of airborne-based systems. For instance, Raytheon and Rockwell both have airborne platforms that are based on the SCA. For instance, the RT 840 from Waco Collins and the ARC 231 and main gate systems from Raytheon are just a couple examples of airborne-based platforms. And there are also a lot of other ground-based systems also. Rockwell Collins and Thales have the FlexNet system, which is a ground-based system. Rody Schwartz has its vehicular tactical radio system. And Thales also has its FlexNet, FastNet, and NextWave families. And Celix also has been very active in the development of a family of radio products from its S-Wave product line. So there are, around the world, a number of manufacturers that have developed SCA-based systems and are deploying those very effectively. So next I'd like to introduce Fabio Castellini from Celix.
Thank you, Ken. Can you hear me?
Yes, we can hear you.
Okay. So from Celix point of view, Celix ES has been involved in the SCA-based technologies and SDR products development since early 2000, both in national and international programs. An important national program, as you were recalling also, is driving the development of a complete family of Celix SDR products called SWAVE, such as an extremely portable handheld device, 2 channels man-pack radio, a vehicular product line which includes 1 channel, 2 channels, and 4 channel systems, and also naval and avionic versions to complete the family, hence covering all the needs and segments of operation. Some of them, like the handheld and vehicular solutions, are already available and fielded to the customer. Internationally, Celix ES participates to most of the European SCA SDR programs, the most important one being the ESSOR, where Celix led the architecture definition. And also Celix is actively participating to the Wireless Innovation Forum. This is just to say that from all these experiences, mainly gathered through product survivability and fielding and related customer feedback, we can affirm that there are great benefits in adopting the SCA-based techniques into the software-defined radio devices. Actually, as you can see, the benefits are both from the customer and the radio provider perspective. From the radio provider, we can say, for instance, we can recall the reuse of application software, that is mainly the waveform, on top of different radio classes based on the same technology. Reuse of software middleware, that is the core of the SCA radio capability management, such as common interfaces for waveform instantiation and control and use. Then we have also the definition and use of an architecture which provides for an approach to radio device internal control that is common through all the radio family. We have for sure more portability of waveform application software across radio platforms due to the basic set of rules defining the waveform structure itself that again are common. Overall, this allows for a shorter time to market, as we have recalled, a better technology and product maturity, overall development optimization, for instance, in terms of number of software implementation of a single waveform or a single software application. And last but not least, of course, the cost reduction. That is a very important factor characterizing also the customer benefits, which also includes, we could say, for instance, using the same platform for different radio applications that are both waveforms and user services. The availability of upgradable and flexible solutions supported the rapid deployment of mission-ready systems, as you can see. But I would say also the life cycle, that is for a better and long-lasting maintenance and operation in terms of a device lifetime, so durability of a single device. That is also the improvement of logistic overall, thanks to the system's modularity and standard interfaces. The availability of products that enable and enhance the interoperability experience and capability, of course, but also the availability of a networking and cognitive solutions enabler, which are the SCA-based platforms, and overall the growth capability, that is the to allow the implementation for future needs, based on future needs and requirements, and even proprietary solutions on top of these platforms, like for instance waveforms, but also security algorithms, user applications, etc. All thanks and due to a common definition approach. To conclude, the SCA is a solution which SELEX believes being an important factor, an important key enabler and technology for the communication solutions of today, but mainly and especially of tomorrow. Thank you.
Thank you, Fabio. So here's not a complete list, but a sampling of some of the waveforms that are available and have been deployed on SCA-based platforms. I'm not going to go through those individually, but you can see a wide range of types of waveforms, from line-of-sight waveforms to hopping waveforms to SATCOM waveforms with the MIL standard 181, 182, 183, networking waveforms like SRW and WNW, and you know, all vintage of waveforms too. Some that have been around for tens of years and have been migrated over to an SCA platform, and other waveforms that are brand new and have been developed specifically on the SCA, such as MUOS and SRW and WNW, coming out of the JTRS-IR. In addition to those kind of individually developed waveforms, either by a vendor or by the JTRS, there are a couple of significant coalition-based activities going on right now. One is COLWIN, which is a NATO-based coalition. And this activity is really in its infancy, just defining what their networking waveform is going to be and just kicking that program off. But a much more advanced program is the SOR program, as Ugo mentioned earlier. And the high data rate waveform that has been developed under that program is quite mature and is undergoing testing at this point in time. So waveform developments, new and old, continue to be happening on the SCA platforms. And now I'd like to introduce David Renaudot from Thales.
Yes, thank you, Ken. SDR technology based on the open and standardized architectures is a prime solution to facilitate interoperability, national or regional sovereignty, and network-centric operations transitions for the forces through the waveforms developments and the porting of the waveforms onto different SDR platforms. SDR, SCA standards are key success factors for reducing cost in porting common waveforms onto different platforms coming from different origins. And these standards bring benefits to the creations of an ecosystem that in fine provides optimized time to market, reduced development cost, and providing the most important, more options to the customers. And Thales in this area has a unique experience in waveform portability and SDR platform reconfigurability thanks to its SDR platforms, SDR waveforms, and as well SDR lab solutions. For example, Thales is currently deploying FlexNet solutions, narrowband waveforms, wideband waveforms, ground waveforms, airborne waveforms, or soldier waveforms on various types of platforms, including FastNet and NextWave. Thales deploys on the US market some GEM PRC 148 solutions. Thales contributes to the European ESSOR program, as mentioned earlier, develops the contact program in France, and as well provides some SDR labs to some international customers. It shows this variety of program, this large variety of program, all using SDR SCA architectures, all with different business models, shows the interest of using such standard approach for leading radio suppliers like Thales in order to better propose solutions to customers, more options to customers. So, thank you.
Thank you, David. So here, talked about the ecosystem in the beginning, and here's an example, a bit of the scope of the ecosystem that is evolving and is available to support SCA development. And the companies that are represented here represent a wide range of capabilities in the value chain of the development of SCA solutions, from radio manufacturers to integrators to subsystem providers, waveform developers, middleware and tool vendors, and educational institutions. So a lot of different aspects of industry are involved in this and have taken up and are supporting the SCA. And from a geographic perspective, that gives you an idea of where these different companies are located. It truly does cover most of the world, where SCA activities are being performed either through radio development or tool development or supporting software development. So, and next, I would like to introduce Rüdiger Leschhorn from Rohde & Schwarz.
Hello, can you hear me?
Yes.
Welcome. I'm Rüdiger Leschhorn, responsible for studies in the radio communications division of Rohde & Schwarz in Munich, Germany. Within the Wireless Innovation Forum, I'm the Vice Chair and also a member of the steering group of the Coordination Committee on International SCA Standards. If you have read the above statements, you might wonder about the term Near Target Development Platform. I'd like to explain a bit this concept within the next few minutes. The Near Target Development Platform is an approach extending the portability support of the SCA and providing an IPR firewall between the platform provider and the waveform provider, respectively the integrator of the waveform. Consider a typical porting task. A third-party waveform has to be ported on top of a radio platform. The traditional and, as we all know, cumbersome approach would be that the platform provider, in the role of the integrator, has to take the available waveform artifacts like UML models, MATLAB scripts, and as far as feasible, source code, and port it in a first step to some general waveform development tools. After that, in a second step, the waveform code is ported from the general tools to the target platform. The target platform is the operational radio. Depending on the circumstances and the complexity, this can be a significant effort. And we have another issue here. This type of porting requires that most of the waveform IPRs, in terms of company confidential data, has to be made available to the integrator. One might argue that a neutral integrator would solve this issue. However, software-defined radio platforms are devices of extremely high complexity, which makes this approach not really feasible. At this point, an approach comes into play using the above-mentioned Near Target Development Platform. So, what is a Near Target Development Platform, or short NTDP? As the name already is telling us, this development platform does have the same architecture, the same processing elements, and also the same RF hardware as the target platform. Functionally, this builds a complete radio, which allows also interoperability tests on RF level without having access to the real target platform. In addition, this platform provides test and maintenance interfaces, which are required urgently by the engineers porting the waveform. Such interfaces normally are not available on an operational radio. Using a near-target development platform for porting is the optimal way to perform this task. It provides an IPR firewall between the waveform part and the platform part, because integration of the waveform can be done by the waveform provider, respectively a third-party integrator, without the need to access the target platform. Transfer of the code from the NTDP to the target platform can be done by the platform provider without looking into the IPRs of the waveform. That's what I meant with firewall. NTDP concepts allow also development and integration of national crypto solutions by trusted third parties. Near-target development platforms for up-to-date SDRs are already available on the market, are tried and tested in customer projects. Thank you.
Thank you, Rudy. And now I will give it to Lee to pass back to Eric.
Okay, Eric, you should now have control.
Okay, so you should see my screen. I'm moving to where we were. Okay. Yep. Can you confirm me, Lee, this is correctly displaying?
Yes, we're seeing your full screen.
Okay. So thanks, Rüdiger, for this last quote from industry perspective during this webcast. And we are closing to the end of this presentation. Oh, sorry, excuse me, I have exposing screen sharing. Do you still see my my screen, Lee?
Yes, it's currently showing Rudy's slide.
Okay, move to the next.
Okay. You're not in full screen anymore?
I'm not. Yeah, I'm not in full screen anymore. Going back to full screen.
Yep. Now you're back in full screen.
Okay. So, my apologies for the inconvenience to the audience. So the last part of this briefing has to do with a brief overview of what we, more or less the speakers of this call, coordinate together in order to move forward via presentations such as the one we delivered today, the adoption and improvement of the SCA. And this has to do with the rationale of supporting the so-called CCSCA, that stands for the Coordinating Committee on International SCA Standards. So the mandate of this committee, who is one body within one of the technical committees within the Wireless Innovation Forum, is to support the harmonization of the SCA standards at the international level for the mutual benefits of all stakeholders. To include defining an industry-driven SCA evolution roadmap for the international community, because things are evolving. The standards are not static or frozen. They are improving as the technology improves. Of course, this is setting a number of configuration management issues, but definitely we need to monitor and impose things concerning the evolution roadmap for the international community. Profiling the SCA spec and related APIs to define internationally accepted variants that are hosted by the forum. Developing extensions to the SCA standards that address any gaps between the defined SCA evolution roadmap and forum accepted SCA specification variants. Providing implementation and certification guides, tools, etc., easing implementation and supporting proliferation. Establishing and managing industry-led certification programs where appropriate. So those are the goals. Of course, things are contribution-driven. And this CCSCA is active, and the management of this CCSCA is active in creating the ground for such activities to take place within the WINF. The so-called management of the committee is what you have right in the middle of the of this picture, the so-called CCSCA steering group. This steering group is composed currently of eight members who are overseeing the activities within the committee. They are working in relation with a number of advisors. The advisors are represented from MODs, reputed active or with a reasonable background on SCA standards. And the work groups depicted here are the repository for the different activities subject to take place within the CCSCA. All of this is reporting to the forum officers and board of directors. The members of the CCSCA steering group are Raytheon, Rollin Trott, Harris, Hindra, Selex, Hitachi Kokusai Electric, A4SO, and Thales. So this makes a pretty spread and worldwide breadth of stakeholders that are managing activities within the CCSCA. The remaining of the activities being, of course, open to any of the WINF members. And just to give you a view of what's taking place and what's on the agenda, this slide is showing the upcoming CCSCA event. First, pretty significant one is the SCA 4.1 workshop that is co-organized with the JTNC. That will take place on the 21st and 22nd November in San Diego. I'd like to express my thanks to Raytheon Corporation for hosting this event, and this will have to do with orienting the direction into which the SCA 4.1 elaboration activities should go, taking the recently published 4.0 as a starting point. Next event will be the waveform portability workshop hosted on the 22nd of January next year in Paris, hosted by Thales, in relation with one of the projects of the CCSCA called Waveform Portability State of the Art, and in relation with working meetings of the SCA project teams, or the different work groups of the CCSCA will meet around that workshop. So the day after, I guess. More information is available at the URL displaying on the screen regarding this workshop. Then we will have the big yearly event of the WINEF, which is the annual US Technical Conference that will take place from the 11th to the 13th of March in I guess it's in the Chicago area, hosted by Motorola Solutions. So we will have as well a number of working meetings of the SCA work groups, and more on this conference can be seen in the at the address display. More globally than the CCSCA, all the WINEF Forum events, because they are all committees within the Wireless Innovation Forum, can be as well monitored at the URL displayed at the bottom of this slide. So we are getting pretty close to the conclusion of this presentation. You can find out more asking questions to any of the two main presenters or the moderator, Ken Nigman, myself, or Lee Perker. You have the email addresses displaying on the screen. And I guess this concludes what I had to say. I will now thank you for listening and turn the page to the Q&A session. So don't hang up. It's now time for Lee Perker to organize the Q&A session based on the questions we've been receiving during the webinar. Thank you very much. Lee, it's up to you.
Sure. Thank you, Eric. So the first question that we received was, can we say that since the US JTNC and Europe's SOR owns and maintains the waveforms, without a standard like the SCA, this model would not work? And so I'll offer that for comment by anyone. Who wants to take the question?
Lee, since the question is pretty long, is there a way you display it?
Give me a second. Okay, I've typed it into the chat window for everyone to see. Unmuted. Fabio's indicated he wants to respond, so I'll let Fabio please proceed.
Okay, Lee, Eric speaking. I could elaborate on the question. So for sure, part of the driver of the activities within the coordinating committee on international SCA standards has to do with coordinating and international, in the sense that obviously the less variation we have across the different flavors of SCA-based standards, the best it would be for the overall efficiency of the ecosystem. So I would say yes, if I well understood the question. It is clear, and it's one of the main motivations for the stakeholders active in the CCSCA, that we need to harmonize as good as we can the different flavors of standards in order to take the best of the underlying technical vision and model for SCA existence.
Thank you, Eric. Are there other people who wish to comment?
This is Ken. The SCA is a very important part of the model supporting the work from the JITNIC and the SOR that allows the portability between the different vendors, either independently, like in the US model, or in a coalition format, like in the SOR model. So that is a key component and enabler of what the JTNC and SOR are trying to accomplish, yes.
Okay. The next question is, in an SDR, waveform is the radio, and the platform is just a stack of hardware to host with an operating environment. Had it not been for the SCA, the waveform would not have been portable on different platforms, defeating the main objectives of SDR. Can we share this view with one and all, and comment, please?
Unmuted.
Who'd like to start?
Eric speaking. I can start. For sure. Would SCA not be there, the landscape for portable waveforms would be much more hazardous and variant across the different solutions. So it would be excessive to say that there would be zero portability without SCA. To be transparent and absolutely clear. But at the same time, portability is a concept that has to do with efficiency. Efficiency is not 0 or 1. What we are trying to do, and what SCA achieves, and what the SCA standards in general, and we like to insist on the importance of devices and services APIs in that story. For portability, it is very important to have as clear and relevant technical specifications that are standardized in order to make this efficiency factor for portability as close to 100% as possible. Of course, push-button portability is not yet there. We are not at a level in a model where you would execute things like you are doing with a Windows program. But thanks to the SCA, thanks to the APIs, we are certainly doing way better than what anyone could do in taking a chunk of software and saying, okay, let's port it to the next platform. It's really an help to have SCA standards. Thank you.
So Eric, that leads to the next question. Maybe you can comment on it as well. The next question that came in was, wouldn't an error interface standard accomplish the same thing?
Oh, yeah. There's a big difference between what SCA standards are doing and an air interface standard is doing. The air interface standard is stating what has to happen over the air in order for two radio equipments to discuss over the air, to communicate over the air. This is the what to be done in order to have correct radios. What SCA is about is entering into the how we do that inside a given radio. Of course, there is the possibility to, if you have the budget, you have the possibility to make your own full-blown ASIC implementation of what is being requested by the air interface standard. It has some issues. One of the biggest, it's quite more a challenge to interoperate with radios from other vendors than interoperating with yourself. And it has been recognized by several different actors that starting from the air interface specification, typically a STANAG or take some other kind of radio standards, it's very often not enough to enable good level of interoperability with the amount of expenses that the industrial market, especially the military market, can sustain. And that's definitely the reason why simply exchanging air interface standards is being recognized, namely, I'd like to quote them by our advisors from NATO, to sharing the specs is not enough, and that typically the reason why there is a very wide interest in sharing more than the spec, eventually moving towards sharing some software among nations, typically, in order to make things easier. So the air interface standard is definitely not the same kind of animal than the SCA standards. It is at the boundary of the radio, while the SCA standards are in the core of the radio between the waveform map and the rest of the equipment. And the reason why SCA standards are there is to do much more efficiently implementation that are interoperable in compliance with the air interface standard. So I'd like to underline, of course we need air interface standards. This is compulsory. But the SCA standards are bringing an addition to the picture that enable the industry to perform things more efficiently and in a more cost-effective way. Thank you.
This is Ken. I would just like to build a little bit on top of what Eric said there, especially the cost-effective part on the end. This is what we have really experienced at Harris. Is we've ported now a number of waveforms out of the JTRS, the JITNIC Information Repository, onto our platforms. And we found the cost of doing the port is significantly less than if we'd had to do the full development ourselves. And that is really one of the key advantages and enablers of the SCA, that we have that part of the port goes much more smoothly than if we had to develop it ourselves, develop the whole waveform ourselves based on just an on-air interface specification.
Thanks, Ken. So next question, we've got a couple more, and just so everyone knows, I think the formal time for the webinar has expired. However, I think the panelists are willing to stay on for a little while to answer the questions as they come in. So we'll continue to answer those as makes sense. So the next question is, do you believe that military communication systems vendors that do not embrace the SCA compatibility are destined to lose their market share? And if so, in what time frame? Anybody want to take that one?
I could, but would be glad if some others would like to start.
David, how about you? That sounds like a question that's up your alley. Well, Eric, maybe you can start, and then others can join in.
Yep. Of course, this one is very difficult question in the sense that there is such a variety of business models that, depending on the business model of a system vendor, you may have some having some niche things or some specific relationships with a number of governments, namely their own government, which could create some exceptions to what I believe is a short answer to the question that would be yes. At some moment there is a fundamental evolution in the ecosystem that is pushing all of us, and it's not evident for all of us. I mean, us, the industry, the prime industry players in this market, to evolve towards this new ecosystem where we are more and more subject to open the radios, to expose things, to team in collaborative programs. This is more and more a demand from our customers. So in front of the industrial models, we are more and more subject to work together, and sometimes we are competitors. So we need to learn how to work together around those standards. And even when we are in a more classical market model where full solutions are required, I do believe it is an essential efficiency enabler to structure the industrial model of around those SCA-based techniques that enable to port waveforms more efficiently, that enable to have platforms capable to host a variety of waveforms. So at the end, yes, to me it's clearly a big turn, a significant turn, and as any change in the ecosystem, the game, and we are not at the end of the game, we will see who has taken this curve in the most efficient way. But only those that will take this move, take this turn, and will survive is perhaps excessive, but we'll see their competitivity and their market share improve. Thank you.
Thanks, Eric. Does anyone else want to comment?
Rüdiger Leschan speaking, Rot and Schwarz. I think Eric pointed out very precisely that it is a question of the ecosystem. Some slides before we saw this nice picture with 20 or 30 companies in the ecosystem. The ecosystem right now is it's like a train. It's moving faster and faster, and it is growing. It has not been that big in the past. It's a process now, and it is really evolving. And if the ecosystem has reached its critical mass, and I think we are very short before getting the critical mass, then we can say that the SCA is for this type of business mandatory in the future. So I think Eric is right. It's a question of the ecosystem. Thank you.
Any other comments from the panelists? Okay, I've got one additional question, so why don't we do it, and then we perhaps can do a wrap-up. So the last question is, any examples of adoption of SCA in the wireless telecom equipment / smartphones domain?
Eric speaking. The short answer is more or less no. But there is lots of good reasons why I'd like to elaborate on. The business model, and we're back to the business model, is definitely not the same between the sphere of military telecommunications, where SCA started from and is developing, and the domain of wireless telecom equipment, smartphones, as depicted in the question. In the wireless telecom equipment smartphone domain, the amount of investment in defining the standard first has nothing to do in terms of involved effort compared to what is taking place in the military arena. The level, so the standards, the spec only, is clearly of higher quality in general when you talk to the cellular phone standards, etc., compared to what we can have in the military. And then it goes on into the development budget that the vendors of cell phones or smartphones can spend or needs to spend in order to implement their radios. And so therefore, this driver of affordability, of interoperability that was insisted upon during this call is way less of interest in the commercial domain. In the commercial domain, what will count are definitely other differentiators, and the competition will be driven by the quality of the equipment, the battery life, a host of things, and typically the way it is structured. Generally, take the cellular phone example. Compared to defense, they are generally buying the complete stack from the guy who develops the hardware, who is developing the file layer, sometimes the Mac layer, with some software that is given along with the chipset. So it is not you don't have the same boundaries between the different actors, and the rationale for portability is way less present, and the rationale for reconfigurability thanks to software reprogramming is way less present to make it perhaps too short, but generally the Velcro approach, what is dubbed Velcro approach, consists in having dedicated hardware optimized and integrated next to each other inside the chipset, is very popular within cellular phones because it proved to be more cost and power efficient than software programming approaches. This is changing. The fact there are more and more waveforms to support is creating issues that make reconfigurability a point of interest. But portability, as far as I know, is not a point of key interest, and all of this sets the rationale for which what created the ground for SCA in the military domain is simply so different in the commercial domain that there are a few reasons why the commercial industry would endorse SCA-like kind of things. Need to nuance that based on what things are taking place at the RRS level, for instance. They are considering a number of improvements and standards, but this has definitely not the same level of maturity compared to what is seen within the military domain. And the reason why is that the business case is definitely not the same. Thank you.
Thank you, Eric. Any other comments on the question before we wrap up the webinar?
Hey, this is Ken from Harris. The question was specifically towards the telecom market, in which case Eric answered that. But I do believe the SCA has been making some early inroads into some other markets like robotics, and is being used there, at least, maybe not in full deployment or anything yet, but the industries such as robotics are looking at SCA and experimenting with it.
Thanks, Ken. Any other comments from the panelists? Okay, with that, why don't we conclude the webinar? Again, I'll just give a quick reminder. The slides for this webinar will be posted online later today. You can find them at wirelessinnovation.org/webinars, tutorials, and resources. And we'll be sending out that link to everyone so that they have access to it. We've also recorded the webinar, and so if you want to, and we'll be posting the link to that as well, and if you want to share that with others or ask others to view it offline, they are welcome to do so. And finally, as a final request, we're going to be sending the link for the satisfaction survey out as well, and we really request that everyone fill out that satisfaction survey. We really value the feedback. So thank you again to everyone in the audience for attending. Thank you to our panelists for participating. Special thanks to Eric and Ken for all the work they did in main presentations. With that, I will close the webinar. Thank you very much, everyone.